Hello, my math rock stars. All right, so we're going to go over lesson 1-3 of Algebra 1. It's titled Real Numbers, okay? Because there are imaginary numbers or fake numbers, but that's in Algebra 2, so that's when you'll learn about those. So right now we're just going to talk about real numbers and their categories. So right behind me, I have some vocab and some definitions. So the vocab is obviously right here, and there's the definitions. I'm going to step off the screen so that you can take a moment to write these down, and then we'll go over them real quick. All right, so our first definition, our first group, is called natural numbers. And no, that's not a hashtag. It was actually a symbol for the word number before it was ever a hashtag. So I'm going to use it instead of writing out the word number. So natural numbers, right? We call those counting numbers. We can do those on our fingers. Also, birthday numbers. They just start with 1, 2, 3, and they go on up. It does not include 0. So that brings us to our next category. So we have whole numbers, and it's basically the natural numbers, but with 0. So there's my 0, 1, 2, 3, and that's basically whole numbers, okay? So then we get down into what we call integers. Now, integers is the first time where they introduce negative numbers. So it's positive and negative numbers. So now you have all your negatives, you have your 0, which is part of your whole numbers, and then you have your counting numbers, which is part of your natural. So the integers automatically include these other two categories. So make sure that you do have this written down. I'm going to add a couple more vocab words and definitions. So hit pause, make sure that you do have them, and then get ready for some more. All right, so we have 2 more categories. Here's their definition, and here's a couple examples. So I'm going to step out of the way. Again, hit pause, make sure that this is in your notes, and I'll be back in just a moment. All right, so now that you have them written down, I'll just go over them real quick. So we have what we call rational numbers. Those are numbers that make sense. And in math, it's any number that can be written as a fraction or what we call a ratio. It can also be a decimal, or it can also be a repeating decimal. So here, look at some of our examples. So right here we have the common fraction 1/2. Now I can say it's a ratio. It's a ratio of 1 to 2, like cooks use them. Here's a fraction, -3/4. And even if I take a natural number, like the number 5, if I put a 1 underneath it, that's why it's also a rational number. Because I can take any natural number, put a 1 underneath it, it looks like a fraction or a ratio, 5 to 1, right? Here's our decimal that actually terminates or ends. So that's, some people just read it 0.125. It's actually 125 thousandths. And then we have a repeating decimal, okay? So 0.333, that 3 is just going to keep going on forever. It makes sense just because way down at the other end of the board, I know it's going to have a 3. Now, that takes us to irrational numbers, okay? So an irrational number, quote unquote, does not make sense. It's not a math term. Math means it cannot be written as a fraction or a ratio. So you can't turn them into fractions. The best example that we have and that you might know of is pi. Not the chocolate pie or strawberry pie, but you remember this little symbol, pi. It stands for 3.14. That's usually where we cut it off, but it does continue on. So it's 3.1415926535897, and it doesn't stop. It just keeps on going. I got tired of writing it. You don't even have to write this whole big number. Just let it know it never stops. So it doesn't make sense. Then we also have some numbers that if you take the square root of, the square root of 3, the square root of 5, these are irrational numbers because you're going to get decimals that might not end with these. All right, so what we're going to do next is, after you have this, you should already have this copy down, is we're going to put some examples up on the board. I'll do some of them, cover them, and then I'll expect those examples to be in your notes, and then I'll probably have a couple practice ones too. All right, so what you can see behind me is I have some example problems, so I will answer these and go over these, and then I have some practice examples. So the practice examples, you write these down on your notes, you try to figure them out on your own, but I'm not going to put up the answer in the video. So this is one of those things that you can ask me after you watch this video, are these the correct answers? So again, on the examples, I'll go over the answers. On the practice, now you have to try that on your own. Okay? So, pause the video if you need to, but I'm just kind of quickly jumping into these examples. So, we just learned about the different categories of real numbers. So here are some real numbers. I want to see what categories they fit into. So first of all, we have a -4. Well, remember, the natural numbers are counting numbers. So they start at 1 and go up. Whole numbers start at 0 and go on up. So -4 only falls into what we call the integers and rational numbers. So that's going to be my integers. And I'm just going to say rat for rational. All right. The square root of 25, that's a little tricky, because the square root of 25 actually is 5. So 5 is a counting number or a natural number. So it is a natural number. I'm just going to say nat. And basically, if you're a natural number, you kind of fit into the other categories, right? Because whole numbers just include 0, so you're part of the whole numbers. 5 is a positive number, so you're part of the integers. And then, of course, you're part of the rational numbers. So I'm going to put rat again. So a plain number belongs in all 4 groups. All right, and then we have -1/2. And as soon as you think negative, a lot of people think, oh, that's integers, positive and negative numbers. Unfortunately, integers include positive and negative whole numbers. So anything that's a fraction or decimal actually just falls under rational. So this is a rational number. Because it is, looks like a fraction, because it is, or a ratio. And then on D at 0.111, looks like it's a repeating decimal. So again, decimals aren't part of natural or whole numbers or counting numbers. So again, that's just also a rational number, like a fraction. Right? So make sure that you get these written down, and then try these on your own. So this is 4 divided by 2, or 4 halves. 0, the square root of 10. Type it into your calculator and see what crazy type of number you get. And then -14. So that's going to conclude the lesson on 1-3 real numbers. So have a math-tastic day.